Hello students, today we'll discuss IB Physics SL Paper 1, May 2021, time zone 1. In this paper you cannot use calculator. My name is Nariman Mealim. I am located in Baku. Here you can see my mobile and email. To prepare for exams, the main sources are main huge textbook from Oxford, short textbook by Tsokos, and to revise and understand better, short Tim Kirk book from Oxford. Already when you are doing past papers, you should have physics data booklet for first assessment 2016 copy, and recommended is IB Physics Guide. Let's start. So this exam took place on Monday, 3rd May 2021 afternoon, 45 minutes. Question 1. Which lists one scalar and two vector quantities? So I made a list of all mentioned quantities, and from this list we realize that D has power is scalar, momentum, velocity are vectors. So choice D. Two sets of data shown below with circles and squares are obtained in two experiments. The size of the arrow bars is the same for all points. So arrow bars are the same. It means that absolute uncertainty is the same. And what is correct about absolute uncertainty and fractional uncertainty of the y-intercept of the two lines of the best fit? So y-intercepts are these values. So for circle it is 3, for square it is 1, and absolute uncertainty is half. So we can calculate this fractional uncertainty. So it is absolute uncertainty by the value. So for squares it will be 0.5 by 1, for circles 0.5 by 3. So for squares it is larger, and absolute uncertainty is the same. So choice D. A large stone is dropped from a tall building. What is correct about the speed of the stone after 1 second fall? Speed is increasing all the time during the fall because we have resultant force which equals weight minus E resistance. But E resistance increases as stone speeds up, hence resultant force and acceleration decreases. Acceleration is rate of change of speeds, hence we have choice D. So it is increasing at decreasing rate. Question 4. The graph shows how the position of an object varies with time in the interval from 0 to 3 seconds. At which point does the instantaneous speed of the object equal the average speed over the interval from 0 to 3 seconds? So average speed is distance divided by time. So distance is from 1 to approximately 3.5. We find difference, and we divide by 3 seconds, so it is 1/17 about. Instantaneous speed equals to gradient of the tangent, and I have drawn here line with tangent 1, and we see that 1 is close to 1/17, so B has two small gradients, D has two big gradients. So C is in between, and it has very close gradient. Tangent to the point C will be equal to the tangent to the instantaneous to the average speed. Question 5. A car takes 5 minutes to climb a hill at constant speed. The mass of the car is so much, car gains gravitational potential at rate so much, take the acceleration of gravity g. What is the height of the hill? So we have given time, power, and mass. Constant speed that means that kinetic energy doesn't change. Not in booklet formula for power. We rearrange for energy change. It will be power multiplied by time. So energy change will be power by time, so much. On the other hand, energy change is gain in potential energy. So we write energy change equals mg delta H. Delta H will be, we rewrite formula for delta H, and we get 600 meters. So choice C. Question 6. A ball undergoes an elastic collision with the vertical wall. Which of the following is equal to 0? For elastic collision, speed of approach equals speed of separation. As wall speed remains 0, hence ball will be moving forward and backward with the same speed, so it has the same magnitude of linear momentum. So change of magnitude will be 0. So they ask what will be 0. Which of the following is equal to 0? Question 7. The two forces act on an object in different directions. The magnitude of the forces are 18 and 27 newtons. The mass of the object is 9 newtons. What is the possible value for acceleration of the speed? So resultant force maximum is sum when they are in one direction, minimum when they are in opposite direction. From subtopic 2 booklet, we have Newton's formula for acceleration. Actually, it is not force, it is resultant force. Acceleration will be resultant force over mass. Hence, acceleration maximum will be 4 meters per second and minimum 1. So acceleration choices in this interval is C. So choice C is answer. Two identical boxes are stored in a warehouse as shown in the diagram. Two forces acting on the top box and two forces acting on the bottom box are shown. So 1, 2 acts on top box, 3, 4 acts on the bottom box. Which is the force pair according to Newton's third law? So 1 and 4 are weights of boxes, so it is forces acting from Earth. 2 and 3 are contact forces, equal in magnitude but opposite in direction, so it is Newton pair for these two boxes. Question 9. Electron has linear momentum so much. What is the order of magnitude of kinetic energy of the electron? So subtopic 2.4 give us formula for momentum. We rewrite it for speed. Subtopic 2.3 give us energy formula for kinetic energy. We substitute our expression for V and we get link between energy and linear momentum. Kinetic energy and linear momentum. Data booklet give us mass of electrons, so we approximate it to 10 minus 3. Then we put values, approximately 8. 8 approximate to 10. So we have 10 minus 19, so choice C. Question 10. Which aspect of thermal physics is best explained by molecular kinetic model? We get equation of state of ideal gas from molecular kinetic theory. It means that choice A is the best choice. Question 11. When 40 kilojoules of energy is transferred to a quantity of liquid substance, its temperature increases by 20 Kelvin. When 600 kilojoules of energy is transferred to the same quantity of liquid in its boiling temperature, it vaporizes completely at constant temperature. What is the ratio of specific latent heat of vaporization by specific latent heat of capacity? From booklet, we get the two formula, one with capacity, another with latent heat of vaporization. We put the values given and then find the ratios that they ask for. So the choice is D. Question 12. A quantity of 2 mole of an ideal gas is maintained at temperature 127 in a container of volumes. What is the pressure of the gas. So subtopic 3.2, we have gas equation. So given information, temperature we change into Kelvin by adding 273. Gas constant we learn from data booklet. So we substitute values, we round, and we get 80,000 kilopascal, so choice D. Question 13. An object performs simple harmonic motion. The graph shows how the velocity of the object varies with time. So what can I remind you that displacement, velocity, and acceleration are linked in this direction by differentiation, in this direction by integration. So because it is velocity, to go to displacement we need to integrate. So here we see cosine graph. So cosine graph is V0 cosine. We integrate, we get sine. To get acceleration, we differentiate, we get minus sine. So we need two graphs. X should be sine and acceleration should be minus sine. So it is choice A. So the first choice suits us. Question 14. A sound wave has a frequency of 1 kHz, wavelength so much. What is the distance traveled by the wave in 2 milliseconds and the nature of the wave? SI units for kilohertz, hertz, millisecond into second. Traveling wave, wave equation. We find speed of wave. Distance is speed by time. We get the distance. And remember the fact that sound is longitudinal wave, so choice C. Two identical waves, each with amplitude x0 and intensity I, interfere constructively. What are the amplitude and intensity of the resultant wave? Amplitudes are added, so we get 2x0. From subtopic 4.3, we see that intensity is proportional to square. So square means amplitude increase 2 times, intensity 4 times. It becomes 4i. So choice D is the answer. Question 16. Three quantities used to describe a light wave are frequency, wave, speed. Which quantity increases when light wave passes from water to air? Frequency stays the same, speed increases in air because it is less dense. From booklet 4.2, wave equation, we see that speed and wavelengths are directly proportional, hence wavelength also increases. So choice C, both wavelengths and speed increases. So question 17, a pipe of length L is closed at one end, another pipe is open at both ends and has length 2L. What is the lowest common frequency for the standing waves in the pipes? So I have drawn the first harmonic, so lowest frequency, and they coincide. It means that let us make it right. So it means that the first harmonic coincide. So node antinode distance is lambda over 4, so lambda is 4L, and from wave equation we get frequencies speed by wavelengths, speed by 4L, so it is choice B. Choice B. Question 18. Two charges Q1 and Q2, each equal to 2 nanocoulomb, are separated by distance 3 meters in a vacuum. What is the electric force on Q2 and electric field due to Q1 at the position of Q2? So I use formula from subtopic 5.1 for electric field and electric force and electric field. So I use K value from data booklet, And I got choice A. Very straightforward question. Two conductors S and T have VI characteristics shown below. When the conductor is placed in the circuit below, the reading of the ammeter is 6 amperes. What is the EMF of the cell? So we see that conductors are connected in parallel, so they have the same voltage, and total current is 6 amperes. So let's look to the diagram. So let's assume that they have the same voltage. If the voltage is less than 4, the sum of currents will be less than 6. More than 4, more than 6. But when EMF or total voltage, not total voltage on each component is 4 volt, current is 3 amperes, so total current is 6 amperes. So choice is 4 volt, choice A. So you can see here my printed solution also. For a real cell in a circuit, the terminal potential difference is at its closest to the EMF when the internal resistance is much smaller than the load resistance. Note in booklet, terminal potential difference equals V minus EMF minus IR. So the smaller the internal resistance, the closer is EMF to terminal potential difference. So choice A. A long straight vertical conductor carries the current I upwards. Electron moves with horizontal V to the right. What is the direction of magnetic force on the electron? So I have drawn this picture here. So by right-hand grip rule, we find anti-clockwise direction of magnetic field into paper at the position of the electron. Fleming's left-hand rule, conventional current for electron to the left, and field into the paper, so force will be down. Choice A. Question 22. If child stands on horizontal rotating platform that is moving at constant angular speed, the centripetal force of the child is provided by friction of the field of the child. So choice B, because the only contact force on child is friction from rotating platform. Which is definition of gravitational field strength at a point? The gravitational force per unit mass experienced by a small point mass at that point. This is definition, just learn it, and choice is B. A simple model of an atom has 3 energy levels. The differences between adjacent levels are shown. What are two smallest frequencies in the emission spectrum of this atom? Smallest frequencies come from smallest energies. Energies are 663.13.3. Using formula from subtopic 7.1 for energy of photon, we write it for frequency and use H from booklet. So approximate it, and we have choice C. Question 25. What is the relation between the value of unified atomic mass in grams and the value of Avogadro constant in mol minus 1? I checked that product approximated give 1. So answer is B. This is a difficult question. 3 particles are produced when the nuclide undergoes beta plus decay. What are two of these particles? So for each I wrote nuclear reaction. So top and bottom numbers should be balanced. They are balanced for A and C, but also lepton number should be conserved. So if we have lepton particle, we should have antiparticle. Because positron is antiparticle, we choose neutrino, not antineutrino. So choice choice A. Question 27. A particle reaction is given. Which conservation law is violated by the reaction? So baryons stays the same, charge is violated, lepton is not violated, conservation of momentum is never violated, so choice B. Question 28. Which change produces the largest percentage increase in the maximum theoretical power output of turbine? So subtopic 8.1, formula for power. To simplify, let's see how these changes affect the value. So in A becomes 2p, so we have directly proportional to area, directly proportional to area is pi r squared. So if you change radius, it will be, okay, area squared. Doubling the area becomes 2 times 2 power. Doubling density becomes 2 power. Doubling the radius becomes 4 power. And doubling the speed becomes 8 power. The larger the change, the larger percentage increase. So choice D is the answer. Question 29. A black body at temperature capital T emits radiation with a peak value lambda p and power p. What is the temperature of the black body and the pi emitted by peak wavelengths of lambda over 2? So subtopic 8.2, lambda maximum formula, power formula. Lambda maximum and temperature are inversely proportional, means temperature increased 2 times because lambda decreased 2 times and p should increase 16 times. So choice D. And the last question is 30. In a simple climate model of a planet, the incoming intensity is 400 watt per meter squared and the radiated intensity is so much. The temperature of the planet is constant. What's the reflected intensity and the planet and the albedo of the planet? So by conservation of energy reflected is 100. By definition of albedo from subtopic 8.2, albedo is 0.25. Choice A. Here we finish the paper. Thank you for your attention.